Hello everyone. My topic for the final project is a case study in healthcare or Topic 33. I will be focusing on the COVID-19 pandemic given that it's been such a central part of our lives over this past year, and there's been a rich wave of data sources that has become available, and I was curious to explore that a little bit more. So this project has two parts. The first part aims to analyze the correlation between COVID-19 medical data provided through Johns Hopkins University and several non-medical variables coming from the World Happiness Report. The second part focuses on estimating and comparing the forecasts from different time series models to determine whether the past trend of the pandemic can be useful in forecasting the evolution of the pandemic death toll moving forward. In terms of technologies, what I'm using for this project is pretty standard. I'm using NumPy and Pandas for data processing, and the entire code is on a Jupyter notebook. I'm using Seaborn and Matplotlib for the visualizations and scikit-learn for the machine learning part of the project. As I mentioned, the data sources are two. One is the GitHub repo of Johns Hopkins University. The main data frames that will be used from this source are on the daily infection rate and the death rates, which we'll use for the time series forecasting. And then non-medical variables will come from Kaggle based on the World Happiness Report. The first part of the project uses a simple linear regression to estimate the correlation between COVID-19 infection rate and other variables such as the income per capita of the countries, the degree of social support and social safety nets that are available to people in those countries, expectations on the longitude and the healthiness of their life, as well as the degree to which people are free to make life choices in the given country. And then for the time series forecasting part of the model, we will be employing three different models. A seasonal autoregressive integrated moving average, which is an unsupervised machine learning forecasting model, and then extreme gradient boosting, as well as neural networks, which we're very familiar with. So for the SARIMAX, one particular characteristic which is important in estimating the model, is that it considers three hyperparameters that need to go into an ordered tuple, and these are P, Q, and D, and this is how the model kind of extrapolates the trend, the forecasting trend. And before estimating it, these parameters need to be optimized, and I will show you that in a bit. And then XGBoost and neural networks, unlike SARIMAX, are supervised machine learning models, and the fundamental assumption is they need feature independence in order to be properly evaluated. Before running the linear regression, I just did some correlation analysis to see what to expect in terms of the non-medical variables and how they influence the maximum daily infection rate for COVID-19 across countries. So all the dots here represent countries. And as you can see, the level of income or GDP per capita, the healthy life expectancy, and the social support are all positively and strongly correlated with the daily infection rate. Whereas the freedom to make choices from this single variable regression scatter seems not to be very strongly correlated. But then we'll see how this pans out once we run a regression with all the variables together. And this is what the slide shows, and here I'm also ranking the features in terms of their importance. So healthy life expectancy and GDP per capita are positively correlated, and they have the highest regression coefficients in terms of predicting the daily infection rate across countries. Whereas on the other hand, freedom to make life choices is negatively correlated, but it has a pretty large coefficient in magnitude in terms of being predictive of COVID infection rates. And these slides will show the results of the forecasting. So the SARIMAX model, as we see here, the x-axis is the date, and then the y-axis is daily deaths, and the orange line is the SARIMAX prediction. So it very closely traces the actual data series, but it slightly underestimates it. And As I mentioned before, for Serimax, we need to optimize the hyperparameter. So this simulation does that. And this is how the order tuple of 313 was determined before running the model. And these are this is the output with the XGBoost, so very similar setup. And here we see that the XGBoost also performs relatively well, but it does overestimate the death toll. And finally, this is a neural network. So unlike the other two models, it seems like the neural network does not capture the seasonality or like the fluctuations very well, but it extrapolates a bit more of a linear trend. However, if we compare the mean absolute errors, the neural network model did turn out to have the lowest mean absolute error. So what did I learn from this project? Well, a very simple fact from a naive linear regression model that could be improved is that the healthy life expectancy and GDP per capita were the biggest determinants of daily maximum infection rates for COVID-19 across countries. They're both positively correlated. And then the linear regression, as I said, is a pretty simplistic model, so it can be improved by adding more variables and also by using more sophisticated estimation methods and comparing different types of models. On forecasts, Serimax traces actual daily data for deaths a lot better than the other two. XGBoost overestimates it, and the neural network predicts more of a linear trend. These models could also be further fine-tuned through optimization and also penalizing for overfitting the data. Additional extensions of the project could include Spark streaming of tweets based on COVID and COVID-19, so extrapolating sentiment variables and incorporating those in the models to see how predictive of infection and death rates those are, but also maybe a geospatial simulation of the COVID-19 pandemic, either in a region or the entire world using GeoPandas. So those are extensions I'm eager to work on moving forward. And thank you so much for your attention.